Today we will be discussing the importance, inspiration, and requirements of Islamic religious practices. More specifically, we will be discussing how and why Islamic scholars calculated the direction of Mecca. Mecca is the holiest place in Islam because it is the birthplace of Prophet Muhammad and the site of the Kaaba. In the Quran, it requires every call to prayer to be in the direction of Mecca, which changes depending on location. In this video, we will uncover how Islamic scholars calculated prayer times and direction to Mecca. We will also discuss other pillars of Islam and why, how, and what Islamic scientists had to calculate. We will focus our attention on salat, inheritance, and zakat. All of these Islamic practices are able to be practiced because of Islamic scientists and their contributions to the mathematical world. The Qibla is the direction relative to location that faces the Kaaba in Mecca, which prayers are oriented towards. Due to the incredible global span of Islam, finding the Qibla in different places of the world requires more complex calculations than one may think. With the rise of astronomical advancements, scientists understood that since the Earth is round, that some simple spherical trigonometry could be applied to determine the global Qiblas. The discovery of the law of sides for spherical triangles derived by Abu Wafa was extremely helpful in these calculations. Al-Biruni was a leading polymath working on the Qibla problem, and he presented 4 different methods to solve the problem. Composition of tables including sets of locations with corresponding Qibla directions were published, a great example being that of the 14th century Mawaqit Muhammad al-Khalili, which contained 2,880 entries. Prayer is a structured facet of Islamic life. One of the 5 pillars of Islam is salat, 5 daily prayers that must be performed at certain time periods throughout the day. This specific time is determined by the position of the sun, which naturally changes depending on where and when on earth the prayer is taking place. Thus, the times change day to day. Today, this can be done by computer. However, medieval Muslims had to rely on human calculation based on astronomical movements. A discipline within astronomy emerged, the science of timekeeping. Mawaqits, or timekeepers, developed tables of prayer times for varying locations. The times of prayer are based on verses of the Quran, the Hadith, and the lived practice of the Prophet Muhammad. The cycle begins with Al-Maghrib at sunset, then Al-Isha at nightfall, Al-Fajr between daybreak and sunset, Al-Sur shortly after noon, and finally, Al-Asr, when the length of an object's shadow is equal to twice the length of the object. Scholars of the medieval Islamic world used rigorous trigonometry. Using the functions tangent and its inverse cotangent in terms of shadow length, Muslim scholars fleshed out much of the field of trigonometry. Muhammad ibn Musa al-Khwarizmi, one of the most prominent and impactful Islamic mathematicians, included in his Book of Wills examples of inheritance and legacy problems and how to solve them. This book takes up such a major portion of the greater Kitab al-Jabr wa al-Muqabala, the first algebra book in history, which proves just how vital calculations of inheritance were. In fact, one element of the Islamic law was the rules concerning inheritance, wills, and legacies. Al-Khwarizmi was able to show just how algebraic these inheritance calculations are in contrast to simple arithmetic. Some cases of dividing estates used fractional arithmetic, but some cases needed slightly more complex algebraic methods. Al-Khwarizmi understood this problem and aligned it with his derivation of algebra, a branch of mathematics concerned with using known elements to decode unknown elements. He thus approached the problems of inheritance and legacies in a systematic way where he reduced the examples into a set type of algebraic equations that he classified in the first part of his book. In Islam, one of the 5 pillars is zakat. Zakat is the commandment to share the community's wealth and is mentioned in the Quran more than 30 times. In order to calculate how much everyone contributes to the zakat, basic algebra is needed. Islamic scientists calculated that everyone needs to donate 2.5% of their money in capital assets to the community. Zakat is significant because it spreads the wealth and helps contribute to economic inequality within Islamic communities. Giving back to one's community is integral, and zakat helps satisfy that desire. Without arithmetic, the calculation of zakat would not be possible. These examples show that a lot of scientific and mathematical discoveries were motivated by certain Islamic practices. This was part of a culture in which Islamic scholars made profound contributions to mathematics and sciences.